Right, here's my hyperbola. And actually, they give us an equation with actual numbers in it, which is nice. X squared on 4 minus y squared is equal to 1. And there's some point x1, y1. So let's pick out a point. I think I picked out something like that. x1, y1. Okay. And the tangent at that point, so it would look like something like this, I guess. There's my tangent. Okay. Tangent. It meets the asymptotes at x, let's put x up there, and y, capital Y. Okay. Show that the product of the length measures, should label my origin here, OX, which is up here, that's OX over there, okay. The product, that times this, there's OY. Show that, required to prove that OX times OY, equals 5. Where'd they pull that number from? Okay. So, if we want to work out OX times OY, I suppose it makes sense that we want to know what OX is and what OY is, and then we can actually multiply them together. You might think, oh, maybe there's a simpler way to do it, but actually the coordinates they give us not too, the equation they've given us is not too difficult. By the way, that 4 there and that 5, that's not a coincidence, okay? So let's try and work this out. Now, we actually know what the equation of a tangent like this is. We actually did it in that previous question. It's x1 on a squared. Now, we don't have to say a squared here because we actually know the number. It's 4, isn't it? So I can say x1 on 4. And then I can say minus y1 over 1, I guess, because my b squared here is 1. So that's it. That's equal to 1. That's the equation of the tangent, okay? Now, it's just going to be a little bit easier if we just get rid of that fraction. So if I just multiply through by 4, y1 equals 4. That's the equation of the tangent. Okay. Now, what am I going to do with that? Well, I can work out the coordinates of capital X and capital Y by solving this tangent, right? I want to solve it with y equals b over a times x, which will give me capital X. And then I also want to solve it with minus b on a x, which will give me this point of intersection down here. Okay, so can we give it a go? How would I go about doing this? I guess it would help if I could, well, where would you start? If I've got this here and this here, I guess y is already the subject here, so I might as well stick it in. So that'll give me x1 minus 4 times b over ax y1, which equals 4. And what do I want? The only variable I actually have here is x. That'll give me the x coordinate of capital X. That's a bit confusing, I know, but they gave us the names, so whatever. All I need to do is really factorize out what's going on here, right? So, oh, and by the way, I was a bit silly. B and A, I actually know what B and A are, don't I? From up here, B is going to be 2. And from over here, A, sorry, what did I say? A is going to be 2 and B is going to be 1, because they actually give us those values. So I can say instead of B over A, I can actually just say a half. Is that okay? All right, so what do I want? I might as well simplify a little bit. x1 minus 4 times a half is 2x y1. That's all equal to 4. And I'll take out that common factor of x, which gives me x1 minus 2y1 equals 4. So now I basically have my coordinates, or my coordinate for x. That'll be 4 divided by x1 minus 2y1. Okay. Now you can go ahead and you can rehearse it for this, but you can actually imagine, because the only difference between solving it for this and this is that negative sign, right? What you're going to get at the end down here is going to be still 4 over x1 plus 2y1, because that sign is going to come along here and it's going to be divided through, and that's what you'll get. Okay. Now you can do the algebra. You can sub that back in to the equations, and you'll get y coordinates as well. And I think this is how everything will work out. You'll get, for capital X, you'll have we already worked out this coordinate to y1, and when you sub that back in to get the y value, you'll get 2 over x1 minus 2y1, because don't forget, it passes through x over 2, half x, so you'd expect the y coordinate to be just half of the x coordinate, and you get the same thing for capital Y, which is 4 over x1 plus, and then this guy's, because negative b over a, it's a different asymptote, so that's why that comes along. Okay, now, I want the distance from O to that, and then O to this, and then I want the product. Okay, now, there are no fancy tricks to get the distance formula, okay? It's just going to be distance OX is equal to, and then you do your square root, blah, 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 okay? Now, it's a bit boring, okay? Here's where you boil down to. You'll get the square root of 20 over, and then this denominator, because it appears twice, it gets squared. So 2y1 squared. Okay, so you can handle the algebra for that. But you notice I'm taking the square root and I have a square on the bottom. So I'm going to get the square root of 20 all over x1 minus 2y1. In a similar way, when you work out OY, you're still going to get the square root of 20, okay? And it's all divided by the different denominator that we had, if you remember these kinds of denominators up here, okay? Now, they want the product, OX times OY. Okay, well, no problem. On the numerator, you got square root of 20, square root of 20, you get 20, okay? And then on the denominator, you have this. Now, just look at it for a second and think. Now, you recognize this. This is just difference of squares, isn't it? Right? So you can factorize that, which gives you x1 squared minus 4y1 squared. But we were not expecting this. We were expecting 5, right? That's what they told us to expect. Now, being that everything else, hopefully, the numbers and all that kind of thing, if all the numbers were right, if we did, in fact, get 20 on the top, then you would expect the denominator to be equal to 4. Well, the question is, well, where did they pull out 4 from? And remember I told you, the actual numbers they gave us were significant, right? So, x1, y1, don't forget, it's on the hyperbola, right? It's on the hyperbola. That means it actually satisfies this equation here, right? So I can actually say, look, x1 squared on 4 minus y1 squared, that should be equal to 1. Because it's on the hyperbola. It satisfies that equation. Now if I just multiply through by 4, you get x1 squared minus 4y1 squared, that's equal to 4, right? Apparently, because x1, y1 is on the hyperbola. But that left-hand side there, that there, is exactly what my denominator is. There, right? So I can say, as x1, y1 is on the hyperbola. That's what I would say. Okay? That means that this denominator is equal to 4. Okay? Which is 5. Okay. Now, admittedly, it'd be pretty hard for us to see that. You'd be like, are you serious? How was I supposed to expect that? That's part of why they gave you the 5, so that when you get to this point, you're like, no, something must be missing. This has to be connected to what I know somehow. It's just a question of what. Okay, so that's how you solve the question.